Thank you, Mark, and thank you all for being here right now. It really warms my heart that people are interested in this topic. So I'll just get right into it. We're all probably very familiar with this phrase, big data. It's become one of the biggest buzzwords of our industry over the last decade or so. And excuse me, sorry, I just realized I need to get this timer going. Right, big data. It's one of the buzzwords of our industry of the last decade. It's totally ubiquitous. It's used to describe this sort of a supposedly new class of problems where we have more information than we can possibly handle easily, whether that means we have more information than we can fit in memory or more information we can fit on one machine, something in that range. But it's more information to process than we can easily handle. And while I have no doubt that those problems are new and original problems, I would argue that the position we're in has actually been true throughout all of history. There's always been too much information to easily handle. Let me show you what I mean. So in the mid-1990s, that's the best we can point as the origin of this term, big data. It came about from this guy, John Massey's Silicon Graphics, speaking in small groups at USENIX conferences like this one. And what you'll notice, this being the mid-1990s, this term actually predates most of the technologies it is currently used to describe today. So that's maybe our first indication that this is quite a perennial problem and not something new. Going back even further to 1924, we have the poet T.S. Eliot writing, "Where is the knowledge we have lost in information?" Again, decrying the information overload of his day in the 1920s. But let's jump back even further to 1621. We have the writer Robert Burton complaining about all the news that's coming out, all of this new information he has access to every day and can't possibly keep up with. New books, new pamphlets, something called a Coranto. All things just driving him insane. Of course, even before that, the renowned philosopher René Descartes claims that even if we could find all the knowledge of all knowledge we existed in books, we wouldn't have enough time to look at it and make sense of all of it. And finally, I'd like to go back about as early as I possibly can to this quote from the Greek philosopher Hippocrates, who says, "Ars longa, vita brevis," which roughly translates to "life is short, art is long." Of course, art is a very general term from back then. The idea of information or data wasn't really a thing. So we could maybe fudge it a little bit and translate to long data, which has some spooky parallels to where we are today. Now, all of this is to show you that I believe data has always been big. Let me pull back and give you a little background on myself. As Mark told you, I am not a professional historian. I have a history background from school, but my current job is working at MongoDB, a distributed database company, where we are very familiar with this term big data. I hear it so much it tastes like water to me. It's not, I'm numb to it. So this is going to be a history talk. For the rest of it, I'd like to go into why and how I believe data has always been big. But first, I want to touch on why it's even worth talking about this at all, because I think it's a little bit unusual to have a talk like this at a conference like this one, although I'm very, very happy that you're here and they're letting me do it. So why should we study history as software engineers? Well, first of all, history gives us a place. It's very enriching, I've found, to know where you're coming from. Even if you believe my argument that these aren't new problems, it's still cool to know that you're participating in this cycle that's been around since the dawn of civilization. I think that's a really cool thing. Next, and perhaps more obviously and more useful, history shows us patterns. If you know history, you can see how people of the past coped with similar things to you, and you can try and predict what might happen and try and, bend the tide of change into your favor. And finally, and kind of counter to that, history also shows us that things are not preordained. As you'll see, hopefully in a few cases during this talk, there are moments in history, especially the history of technology, where ideas and people come together that could have never predicted the change that they were going to make or the implications their ideas would have on other things people were working on. It's really impossible to know where we're going, and that's incredibly freeing, powerful information. So with that in mind, I'd like to go about showing you that information has always outpaced our means to comprehend it, precisely because comprehending it, the process by which we comprehend it, always ends up creating more information, creating this virtuous cycle that we're never going to eclipse. Oh, maybe not never, I don't know, that's a different talk. So if we want to talk about history, why not start at the beginning? Like the very, very beginning. So humanity first emerged as a set of species around 2.5 million years ago. And for the vast, vast majority of that time, we really weren't doing all that much. We weren't even a dominant species back then. We were solidly in the middle of the food chain. Scientists believe we were likely scavengers, using tools to break apart bones and scoop out the marrow. And then something somewhat miraculous happened around 70,000 years ago. For reasons that we still don't understand, humanity underwent a cognitive revolution, and we developed the most essential tool to our species. We developed a complicated, powerful language, a spoken language. Now, languages are nothing new in the animal kingdom, right? Anyone who has a pet dog or even a pet cat can tell you that, right? Like a different bark might mean a different sort of issue has come up. But most animal languages are very limited to say like, danger, danger, I'm hungry, hey. But human language allows for much, much more complicated, useful things like, hey, I saw a lone bison across the river where those 2 fruit trees are. Let's go and kill it, and then we can have it for dinner. That's a huge innovation, right? And so once we've established these abilities to communicate, it allows our tribes of hunter-gatherers to grow beyond sizes that they had for the previous few million years. And that starts to butt up against our first problem, similar to the problems we're experiencing today, which is that tribes were getting so big that there were too many people to know. Some of you have maybe heard something like this before, but psychologists generally believe that we can only really know about 150 people. And there's all sorts of debate about evolutionarily why that's the case, but it's hard for us to keep track of more than 150 people and see them as real individuals and know their needs and desires and work with them properly. And that created a problem for these tribes that were being more successful in growing because you really could only cooperate with your extended family, as it were. It turns out the way that you solve this is to use that the way you get around these limitations is to use that new language that's become so powerful and start telling each other stories. Now, when I say myths here, I don't just mean myths or the things that we typically think of as myths, like humanity exists because they arose from the fourth underworld or something like that. Although those are definitely play a part. It could even be things about like what makes someone a good person? What are the valued things that we'd like to see in our society? And those are very useful because once we have these common stories that we're building our lives on top of, we can sort of know people without really knowing them. If you and I have the same ideas about what is good, then we can trust each other and we can cooperate and we can trade and we can do all kinds of things. Now, personally, I don't think this is an especially intuitive, or at least for me, this wasn't an especially intuitive idea, so I'd like to walk through a much more contemporary example. So let's take IBM. I'm going to ask you a very abstract hypothetical question here. What is IBM? Just think about it for a second. When I first tried to answer this question, I came to this idea of, IBM is obviously, it's the people and the capital. There's a group of people and machines and things like that. But I don't think that's necessarily the case because, first of all, the people that started IBM, they've all been dead for a while now, so it can't just be that. I'd put it to you that IBM could probably fire all of their employees and sell all of their equipment, and they would still exist. Because it turns out what IBM actually is a version of a story we started telling a few hundred years ago called a corporation. Right? This is a very fancy ritual that we've performed. We have these high priests who ordained IBM as an entity with this piece of paper that allows them to do business. And on the flip side of that, if you wanted to get rid of IBM, you would do something like bring antitrust laws against them that would split the company up. And at that point, IBM actually would stop existing, even though the people in capital wouldn't have gone anywhere. I bring this up as an example of the organizational power of myth because, as many of you know, IBM has something like 400,000 employees globally, and you can bet they're not all in the same extended family. Going back to back to our much earlier time, the use of stories to bind people together has allowed civilizations to grow beyond a few hundred to a few thousand people, and humanity has settled down and started to develop agriculture. Now, this is actually kind of a raw deal, in case you didn't know. Once people stopped being hunter-gatherers and started growing their own crops, first of all, people had to work, instead of 30 hours a week, they started working 60-plus hours a week, and their life expectancy fell by half. This might have been the worst decision humanity ever made. But because this is a talk on the history of information, I'll try and focus on the positives. So because of this development of agriculture and our focus on staying in one place and worrying about the future, we've developed all kinds of new technologies related to growing crops, construction, furniture. We have to start looking at the stars in order to figure out when to sow our crops, when to harvest them. Additionally, these large settlements allow for the first presence of social hierarchies, or like large institutional social hierarchies. We start having upper classes, we have elites, we have government. I know I said I'd include this on the good side, but one of the interesting things, though, is that these new governments, they encounter problems that are completely unprecedented for their time because they need to keep track of all these resources people are producing so they could tax it. And that brings us to a problem that is very, very similar to what we're tackling today. They have too many numbers to keep track of, right? As we all know, humans are naturally not good at keeping large data sets in their head. And this being 100,000 years ago, they didn't really know what to do about it. Until around 3000 BC, when an enterprising person in Mesopotamia solved this problem by taking a sharp stick and some wet dirt and changing the world forever. Now, I don't want you to get ahead of me. Writing initially was this very small representational thing. It was basically just accounting. It could let you keep track of amounts of things. It could not at all emulate spoken language in the slightest. It was basically this, and very few people could do it. It was essentially this elite profession of highly skilled information technology professionals, if that sounds familiar to you at all. Early number systems were, not to undersell them, this is the Sumerian number system. You might notice that it is base 60, and this is of course still carried on in the way we tell time today, for better or worse. And although this looks like a very primitive way of keeping track of information, it wasn't enough to stop Sumerian mathematicians from, say, solving the Pythagorean theorem years before that Greek guy was ever born. Here's just one example. First of all, I do think it's kind of funny. Writing was originally a very temporary thing. It was just meant to do some basic bookkeeping, and you throw it away at some point. The reason we even have old documents like this one is because buildings of the old world, for whatever reason, tended to just burn down a lot. And so as a result of these accidental fires, we have records of what kind of bookkeeping they were doing. In this example here, we have an amount of barley and an amount of time, and in the lower left-hand corner, this is very interesting. We have what or what archaeologists believe to be the first instance of a written name or signature. This guy, Kushim. Kushim was, again, just a bookkeeper. He's one of these accountant types. And I do find it kind of thrilling to learn that the first written name that we know of in all of history isn't a hero or a conqueror or someone like that. It's just one of these IT guys. And again, not to oversell this kind of writing, there are, of course, other ways of representing numbers with the physical world. This is a South American quipu, or talking knots, where amounts of things like the grain and the example we saw on the previous slide are instead encoded in these different colors and lengths and orders of tied knots. This was actually such an effective way of keeping track of things that Spanish invaders adopted them while they were destroying the people that invented it. The next big innovation in writing, in written information, comes not in one small burst, but over the next few millennia. Writing slowly becomes a fully expressive language able to completely emulate just human speech. This is an incredibly powerful innovation because it allows those stories that I was talking about earlier that bind people together and allow for society to exist, it allows us to actually codify those in a physical form, which ended up upsetting quite a few people. And let me explain why. So for most of human history, the stories we told each other were all passed down orally. There was an oral tradition to everything. And this includes the great works of Homer, so something like the Odyssey or the Iliad. Basically, any religious tradition also started in this way. And there are benefits to transmitting information through oral memorization. It turns out that you are actually much less likely to make mistakes when you do that, because when you're repeating things to someone, there might be someone else in the room to say, hey, no, sorry, you got that wrong. Contrast that with the evolution of the Christian Bible, which was transmitted over a millennia through written words, just people copying over and over. And we have things like wording changing. We have whole stories showing up kind of out of nowhere. It is actually a lot safer to do it through oral memorization. The other arguments against writing generally is of the form that it makes you stupider. So this is a very, very long-winded quote from Socrates basically arguing that writing doesn't actually make you smart, it just makes you look smart, but you'll forever be dependent on reference materials. And he's not wrong. A Chinese writer named Sushi put this much more eloquently, just referring to it as sloppy learning. And again, I think there is total validity to some of these arguments. But you can't ignore the irony that we only know they said these things because they were written down. Now, all this said, I think the benefits of writing are obviously outweigh these sort of drawbacks, especially when you consider the impact that writing had on human cognition. Writing changed things in a way that that person with a sharp stick in Mesopotamia 5,000 years ago could have never anticipated. Because when you have a fully written language, you're able to think about information outside of the people that are saying it. You're able to do this sort of metacognition. You can think about thinking, and you can talk about arguments without talking about the person who is arguing. Eventually, you develop formal logic. Formal logic, interestingly enough, develops independently in China, India, and ancient Greece around the same time for precisely this reason of the proliferation of writing. And if you're an ancient empire and you have this new formal logic, you can use it to develop all kinds of cool new technologies and innovations that can make your empire very, very rich. So what do you do with that wealth? Well, one thing that you might do is put it into a giant work like a great library. This is the library at Alexandria in Egypt. Historians believe that at its height, it stored hundreds of thousands of individual scrolls. which is a lot. If you're like me and you hear that information, you have a few questions. The first one is, how do you organize 100,000 scrolls? The short answer is that we don't precisely know. But we do know that libraries back then did have an idea of alphabetical ordering. It wasn't as good as what we have today. It was basically just, all right, it starts with an A, put it over here. If it starts with a B, we can put it over there. And there's really no ordering to those piles aside from that first letter. The second question is, how do you even amass 100,000 scrolls? Well, the way they did it at Alexandria was pretty clever. Alexandria is, of course, this massive trading port at the time, and they have this rule that if you ever want to come in to trade, you have to surrender all of the books you have on board so that they can be given to scribes at the library that make really hasty copies, and then they take those copies and they give you the copy. This is a great way. People kept coming back. I don't know. Of course, if you've ever heard of the library at Alexandria, you probably know of it because it's an example of the fall of Western civilization. The Roman Empire eventually gained control of it, and the Roman Empire collapsed in around 400 AD, leaving us in the Dark Ages. Surely during this time, this cycle of information growth and management I've been talking about is going to break down a little bit. Well, actually not, for a few reasons. The principal of which is that the Dark Ages were in Europe, and the world isn't just Europe, it turns out. So, for instance, during this period in China, because of this focus on civil service exams in order to work inside the government, which is a great job if you could get it, people start developing all of these reference materials and study guides to help you ace those tests, not unlike the SAT preps and Cliff Notes of today. And a few enterprising people realized that when they're creating so many copies of the same small piece of work, they could instead just carve those letters onto a piece of wood, dip it in ink, and invent printing. Now, there are some drawbacks to this, especially wood breaks down very easily. We'll get back to that later. Additionally, to accommodate these study guides, we start seeing new methods of binding information together. So you can see this butterfly binding here, which is much more similar to what we would consider a modern book. And this is a huge innovation for this purpose of studying over, say, a scroll, for the same reason that you would rather store your information on a solid-state drive than on a tape drive. It allows for random access. Meanwhile, in the Arab world, we have huge innovations in mathematics, including this invention of the Arab numerals that we still use today. Although it's funny we call them Arab numerals or Arabic numerals because they were actually invented by Hindus in what we would now call India. But all the same, these Arabic academics, they invented things like algebra, and they, as you can see in this example here, made innovative use of things like color and layout in order to add extra textual information to the work they were creating. But hey, even in Europe, things weren't so bleak. For most people, life had gotten dramatically simpler than it used to be, but the Catholic Church was still this global multinational entity, and there were still plenty of works happening during that time. For instance, this Frenchman, Hugh of Saint Cher, he undertakes this incredible big data type project in 1200. He wants to write a biblical concordance. If you're not familiar, a concordance is basically an index on the Bible, but not like the index that you would have in the back of a science textbook. It's an index in the same way that a search engine might index something, right? It's an index of every single usage of every single word in the text. Now to do this, first of all, he needs the help of about 500 Franciscan friars. So 500 people working for years on this project. I actually have to wonder how quickly you could do this today on just this MacBook right here. But in order to make the book useful, you do need to develop a way to easily look up specific words inside of it. You need to be able to order every word. And so the development of a concordance leads us to strict alphabetical ordering. No one had done this before. Like I mentioned, The alphabets had an order. People were using them to store things in ancient libraries. But until this point, no one had actually thought of ordering words based on comparing letter after letter after letter. And for centuries after this time, people still talked about strict alphabetical ordering by referring to it as ordering in the style of the Concordance. So we can see all over Europe and Asia, lots of innovation is happening, and it's just waiting for a spark to kick off the next great wave of human ingenuity. And unfortunately, that spark comes in the form of a plague. This is the Black Death, illustrated here by people of the time as a bunch of dancing skeletons. This is a very common motif I don't quite understand, but that's how people of the day saw it. It was a huge tragedy. From the years of 1346 to 1353, around half, 50% of Europe died. This is, of course, very tragic, but with the distance of history behind us, it's impossible to not talk about the economic effects that something like this has. Specifically, everyone who died left their stuff to the people who lived, and now everyone has twice as much stuff. Hey. This kicks off a huge economic boom on an individual level. People are finally buying things that they hadn't bought for centuries. They're buying gold jewelry. They have an interest in books again because maybe a few more people can afford them. But once again, books are still a limited resource because the only people who can copy them fast enough are these highly paid information technology professionals who know how to read and write very quickly. That all changes in 1439, where a goldsmith, again propped up by these sales of jewelry that came in the wake of the Black Death, looks at these highly paid information technology workers and thinks, hey, I could disrupt this a little bit. He looks to China, he sees this woodblock printing they're doing, decides on a system of movable type and makes the letters out of metal. And again, he was a goldsmith. He makes them out of metal instead of wood, so they last for a very, very long time. You probably know where I'm going with this. I'm talking about Johannes Gutenberg and the printing press. Now, it's hard to overstate the impact this invention had. It totally democratizes knowledge. Within something like 50 years, there's maybe 20 million new books. It's just an astounding amount. You don't have to be the richest person in the world to own one of these anymore. But it also has impacts in how research works that I think are a little less obvious. For instance, because there's so much more book binding happening, there's a lot more paper, and paper becomes very, very cheap. And for the first time in human history, paper is cheap enough that you can take notes on it. Previously, what people would do when taking notes and doing research is they had these wax slabs that you would scribble on, and you would write down the things that ended up being important from that, and you would just sort of wipe the slab clean and start again when you needed more space. Once people could write notes on paper, they could save and aggregate their notes and use them later, which first of all led to new problems of, hey, how do you organize notes, which one enterprising Renaissance researcher solved with this note closet, essentially a bunch of coat hooks that you hang pieces of paper on. Yeah, I think this was not common, I need to say. This is not a common invention, but I do think it's pretty fun. And things like this allow people to generate new kinds of works just based on aggregations of notes. We start seeing things like encyclopedias, which further democratize general knowledge and allow people to innovate even faster and generate even more knowledge. There are limits to this growth, though. There is one thing that printing doesn't necessarily solve, and that's that math is still boring and hard to do. I'm talking about like multiplication and things like that. The other problems, I think, are very fun. But computers did exist in the Renaissance, by the way. It was a job that you could have where someone paid you to multiply and divide numbers all day. And so the cost of doing these kinds of computations was a big inhibitor to growth in science, growth in technology, until someone went ahead and implemented a solution, and this was news to me, logarithms. So these are discovered by John Napier in 1614, and together with this guy, Henry Briggs, he builds these tables, these lookup tables of logarithms that you can use in calculations. Now, this is something they did not teach me in school about how useful this kind of process is, but basically using these logarithm tables, you can abuse properties of exponents to turn complicated multiplication problems into addition plus a few lookups. This can shave orders of magnitudes of time off of large computations and enables things like complicated finance. Institutions like the corporation I talked about earlier really thrive with innovations like this. The work this does allows things like the Industrial Revolution to take off. The problem with these tables, though, is that they're still generated by people, and as we all know, people doing math, mistakes are bound to happen. One study found dozens of errors across different reference books like this, and even more worrying, most of the books seem to share a lot of the same errors, implying some pretty dirty copying was going on. This is, of course, a very dangerous thing because these tables are used to plan trips across the Atlantic. People could very legitimately be killed if some of these numbers are wrong. That takes us into the middle of the Industrial Revolution with a mathematician and inventor named Charles Babbage, who has this inkling that perhaps we could use a machine, an infallible machine, to generate these tables of logarithms. So he puts his proposal together and he gets some funding to try and tackle this problem, developing plans for something called the difference engine, which is meant to generate these tables and even take humans out of the process of, say, laying out the numbers to be printed. It was all automatic. Or at least it was in theory. This is not something he ever finishes. After 10 years of hard work with no real physical objects to show for it, his funding gets taken away, which is very tragic, but I think also a little bit understandable. Not one to be set back by this, Babbage doubles down, spending the rest of his life working on an even more complicated mechanical calculator called the Analytical Engine, which is like the difference engine, except it can be programmed. This is something that I think a lot of people in the computer science field have heard of. It's typically referred to as the first programmable computer, and Ada Lovelace, this woman that he worked with to write algorithms for it, is generally seen as the first computer programmer, which is really cool. But again, this thing never reached fruition. It was never built. And if it were built, it'd be something like the size of this room, and imagine fixing an error in it. It was all gears. But what is worth talking about with the Analytical Engine is what Babbage decided to use to put inputs into it. And to understand that, we need to understand the fashion of 19th century Britain. People were really into fabrics like this, very flowery Paisley numbers. And it turns out these things are very, very expensive and difficult to weave by hand. Because you have to, for every single row of thread, you have to find all the counter threads and pull them up. And if you make a mistake, you could ruin the entire thing throughout days of work. It's just a very dangerous thing to be doing by hand. So for centuries, people have been trying to automate this process. The first attempt we see at it just so happens to come from this guy, Basile Bouchon, whose father worked as a constructor of automatic organs, which I don't have a picture of that because they're quite large and hard to look at, but you can see this music box on the left. It functions by the same principle. An automatic organ has these pegs on a cylinder, and as they turn by, they hit levers and make sound. His son, who had ended up in the garment industry, thought perhaps we could adopt this technology sort of in reverse to power this complicated Paisley weaving. And so he designs this system of a roll of paper with holes in it, and as things try to go through those holes, it determines what threads are lifted, and you can automate the process of weaving. The problem is paper is very, very weak. I don't know if anyone's ever owned a printer. These things jam. And so that goes on the shelf for decades until someone who gets all the credit for this invention, Joseph Marie Jacquard, decides instead of using paper, he's going to use a series of punched cards to do the same job. And of course, those punched cards are what Babbage decides to put in his analytical engine. I believe the smaller ones are instruction memory and the larger ones are data, in case you're wondering. Of course, that goes on the shelf for a few more decades until we look to America. The Industrial Revolution, of course, enables all this new immigration to occur, and someone's got to count all of these people. The problem is, in 1880, the census took 8 years to complete, and it was projected to take even longer than 10 years the next time around, so the government had a problem. Fortunately, this guy, we're back to the problem we started with. There's too many people to know. Fortunately, this guy, Herman Hollerith, says, I think I have a solution, and he's contracted out to develop a machine to mechanically tabulate the results of the 1890 census. His machine utilizes these punch cards that Babbage was focused on. So like if someone was a male, you punch a certain hole and things like that. And using electricity and a series of electric needles, you can bring a lever down and automatically increment counters in this device. His invention is a huge success. The census takes 6 years instead of 8 and finishes with about half the budget, which is exactly the kind of marketing any tech company would love to be able to promote these days. After the census, Hollerith finds he doesn't actually have too many clients outside of the Census Bureau who are looking for this kind of work, and so he combines with a company that specializes in making these scales that tell you how much things cost, and these other companies that are building these clocks that write timestamps. And they become the Computing, Tabulating, and Recording Company, which a few years later rebrands as International Business Machines, or IBM. Now, I think we all have some familiarity with what might happen at this point. But what I will say is in the first half of the 20th century, I think it's easy to imagine that the kinds of problems that IBM was working on seemed just as out of reach as our current big data problems today. These weren't things they could all keep in memory. Like these are huge undertakings. And so with that, I'd say that data has always been big, and the cycle is still going on. Thank you. Do we have time to questions, or do we need to close up?
No, we definitely have time for questions. If anyone would like to approach the microphone to ask their questions, because it is being recorded. Well, I certainly have some questions. First of all, thanks for an amazing. Okay, go ahead.
No, go ahead.
I'm still forming my question. Go ahead.
Okay. Do you want to say it into the mic?
Yeah, let me get a little bit closer.
Hi, camera.
So first of all, I love the allusion to storytelling, because that's something very close to my heart. And some of these stories, I think, as you pointed out, are the modern corporations that we live and work by today, and they've invaded our lives at a deep level. One of the other things you mentioned was Robin Dunbar, a psychologist, and his 150 people that we can know. He also pointed out that as the depth of the relationship becomes more intimate, as we become more experts on a particular person, we can have fewer of these relationships. And I wonder if you saw any of that in history, about how expertise has sort of limited our capacity to understand knowledge through these relationships.
I think expertise limiting knowledge, you definitely see something like that with the foundation of agriculture and civilization. People do become much more tightly linked to certain units in their day-to-day lives, and they become hunter-gatherers were, of course, incredibly knowledgeable people. As you become specialized, you tend to work with a smaller group. Although I don't know if I could espouse on that much more than that.
It's also cool, the relationship to language, because specialists develop their own languages as well, which makes cooperation between them harder, right?
That's very true. I don't know how much that was true until the modern era, but that's actually, yeah. I mean, we're at a conference of that right now.
Sure. Did the other question disappear, or did it?
That's fine.
Okay. So,
Sorry.
Last question: will the dancing skeletons of the Internet of Things be a plague upon our modern society?
I'll leave that as an exercise to the listener. All right, thank you.
All right,
I
Carl,
think
thank you so much.
Thank you
for
so much.
Super interesting talk.
Thank you all for coming.